All right, everybody, welcome to IndyPy, our September 2021 edition. We are doing our afternoon sessions here, and I'm going to move my video people out of the way here so they're not blocking my view of the slides themselves. My name is Hendryx-Parker. As I mentioned before, I'm CTO and co-founder of 6 Feet Up. We love Python and have loved Python for a long time. And it always delights me when I get to find a new way, a new reason to explore parts of the language and then share it with others. And so this is one of them. I want to tell a little bit of a story of how I learned some Python async really quickly with 42 lines of code. My problem, my thing I wanted to solve was, as I'm going to various events and various conferences, I want to be able to follow the people on Twitter who are speaking at those events. And so I want to quickly make a Twitter list of all the speakers to start with, any organizers. But going from, here, I'll show you kind of the example here. If you wanted to do that, you'd have to go to a speaker page on a conference. You'd have to go find all their Twitter links and copy all those Twitter links and then go make a list and put them into like your TweetDeck or your Twitter list stuff, which can be a pain in the butt. If anyone's ever done that or tried to manage Twitter lists by hand, I was like, there obviously is a better way. And it obviously has to be Python. Because Python's the easiest way to scrape some stuff off a website. So let's talk about how we did that. If I go back over here to the slides, I started off pretty naive, pretty simple, is I'm going to just use requests. I'm going to grab the URL. I'm going to use Beautiful Soup. And you all have seen me do this a dozen or more times because this is basically the same pattern or technique I do for the door prize drawing, which is to go grab the RSVPs off of meetingplace.io, use Beautiful Soup to select out all the names, and then build a list. And then at the end, I just print out a return separated list of all the Twitter IDs, because that's what TweetDeck wants when you want to paste it in and create a list really quickly inside a TweetDeck. So that's what we got here. Actually, I'll show you that running because it's probably more interesting to see real code running than it is to just listen to me blather on about that. Actually, I'll go over here to where's my terminal? There it is. Here we go. One page. So in a single page situation, I'm going to actually scrape that Python WebConf 2021 speakers page. And here we go. Boom. 0.27 seconds. Nice and fast. Very easy. But it's also only grabbing one page and grabbing all the Twitter handles off of that. And I can just now copy paste this right into TweetDeck. And away we go. Which is cool. Very fast, very simple. Now, events don't always list speakers in one page. I was like, oh man, this is getting complicated. So my use case here was I wanted to create a list for this year's DjangoCon Europe because there's some awesome speakers on there. And I wanted to make sure while I'm at the event, I'm following all of them. But the list of speakers, this is kind of powered by their Call for Papers platform. Each speaker, you have to click through to that speaker, and then they've got a link to their Twitter and other socials in there. But so it means that for every speaker in this list, I need to go to every one of those pages and grab their Twitter bio. So if we look at how that's done, I basically made a, grab each speaker one by one. So I pass the URL to the speaker and I go and look for each speaker in there, I call grab Twitter. So this is the speaker page just passed here. I go and find each of the speakers, and then I go in and I basically loop over each speaker, calling a function I called grab Twitter, which passes it in the speaker's link. And if we look at how that works, the grab Twitter functions like this. It's basically passing an URL. I've got a base URL set up so that I know where the speaker pages are all at. I use Beautiful Soup again, and then I loop over for link, in my Beautiful Soup of like Twitter stuff, find and grab out the URL for Twitter again, and return that Twitter link back to me. All right, the sadness is now what happens next. Oops. Is that basically every time I loop over, this is all done in series instead of in parallel. So it took me 24 seconds to run across all the speakers who are part of the DjangoCon Europe sessions instead of the less than 1 second it takes to grab one page. This is where it all dawned in my head. I'm like, if I could only do these all concurrently at the same time, hopefully not tearing down whatever server I'm hitting, but it should be pretty reasonable. I'm only going to grab a handful of pages all at once. But if I could do them all at the same time, I should be able to basically make this request in the time it takes to do 2 requests. The first request being for the speakers page with all the speakers listed, and the second request being the time it takes for one speaker's page, but they're all being done at the exact same time. So let's see if we can fix this problem. So let's add in some async. First thing I did was requests is not an asynchronous library. There's quite a few other options out there when it comes to asynchronous libraries. Actually, one second, let me move that over here. I forgot about all my like fabulous speaker notes, but I should be able to now. Windows are not cooperating. There we go. Now Windows are cooperating. There's plenty of options out there in the ecosystem when it comes to asynchronous HTTP libraries, but I found HTTPX. It was mentioned to me on a Python Bytes episode fairly recently as the asynchronous alternative to requests. What's nice about HTTPX is focus on performance. It has got lower latency across requests. It has reduced CPU and round trips. It strives to reduce network congestion. Another nice feature is it also supports cookie persistence across requests and HTTP2, which I know request out of the box doesn't support HTTP2. And if you want, you have to add in some kind of plugins to be able to support those additional bits. So we've got HTTPX plugged in. What's nice is also it's basically a drop-in for requests. So now we've got an async library to play with. But I'll just go back here. That asynchronous library didn't help me yet because the requests are still going to be done in series. We're going to have to do a little more work. But let's take a little detour on HTTPX because I really am enjoying it. And this came in my Twitter feed this morning, is that HTTPX is at a 1.0 pre-release. So if you try out, you can actually try out HTTPX from the command line. There's a pip install here, which I'm going to give you a better command to do to get HTTPX installed if you want to use the CLI tool. And I'll show you that here in a second. But it is almost a drop-in replacement for requests. There's a couple little gotchas. They're mentioned in a nice little documentation page. So HTTPX has some pretty decent docs. But big one that might catch you is that HTTPX doesn't follow redirects by default. So if you are relying on requests behavior to follow redirects, you're going to need to pass an extra flag to your GET, POST, or whatever your request is to make sure that you get that same behavior to follow requests. The request session is pretty much the same thing as an HTTPX client, which allows you to share those cookies across the requests, across multiple requests. When you get a response back from HTTPX, response.url in the request world was a string, but in the HTTPX world, it's going to be a URL object, which gives you a little more power and flexibility. Under the covers, HTTPX is using HTTP core, which is developed by, so we had Tom Christie, who is also, if you aren't familiar with Tom, he is the creator of Django REST Framework, Starlet Framework, and Uvicorn, just a prolific man. I don't know when he sleeps, but he also is one of the maintainers of HTTP core, and it's a replacement for URL 3, which is also a nice library, but I think they decided on making their own for various reasons. Last gotcha is that the request body for things that don't normally take a body in their options or in their arguments, like get, delete, head, and options, you cannot pass in content files, data, or a JSON argument to those. You would have to work around that by using a HTTPX request, specifying the method type, and then specifying one of those body options as part of the requests. But if you want to use it from the CLI, which is part of the new version, so this is part of HTTPX, the 1.0 pre-release, you can do it, but it's a little tricky. So I wanted to give everyone a little quick demo on how to do that. So I would recommend to folks use pipx if you're installing command line tools like this. I showed this off in another talk when I talked about bootstrapping Python, but it's a nice way to sandbox just tools that I want to use in the command line that are not necessarily part of my project. Things like Black or isort are awesome tools. So I'm going to give another plug for pipx. It acts a lot like pip, but gives me the option to install into its own little virtual environment. And then it puts the binary, like any scripts that would have been generated as part of like HTTPX, like the command line tool, into my path for me automatically. So here we're going to pipx install. You have to specify the CLI and HTTP2 if you want to actually get those additional dependencies installed with HTTPX. And now with HTTPX, we can actually come in here to the pet store, use HTTPX. Oh, that was, well, pet.com. But you get the idea. I can now call any URL, JSON or not. You could be regular web requests, and it will use the HTTPX library under the covers. So I'll just actually go grab like 6feetup.com. You can see all the headers. You can get all the HTML. What's nice is it also does all the like syntax highlighting, so you get the pretty output coming to the window. It's a great tool for poking at APIs or testing your own APIs. So I highly recommend folks check out the command line tool version of HTTPX itself. There's a link here to the project. I have a resources page at the very end of the presentation that talks more about some of the tools and libraries that are used as part of this. So it's also, there's another tool you may buy. Why would I use this instead of HTTPy? And if you've never heard of HTTPy, you should definitely check out that tool as well. Another command line HTTP tool similar. It has a little more flexibility in command line arguments, but it doesn't, the HTTPy out of the box, at least it did when I last checked it, doesn't support HTTP2, which if you're trying to test something HTTP2 or trying to test headers or connection issues, it's nice to have HTTP2 because that's what a lot of modern browsers are going to use as they connect into your APIs or to your websites. All right, all that said, let's actually change this up and change our two functions to really be asynchronous and take advantage of the async client that's part of HBX. So the change is not super tricky, but I think if you've never done it before, it can seem a little daunting. So first things first is we have to make our function awaitable, which means we basically make it an async function instead of a regular Python function. And we're going to replace our HTTPX calls like requests with using an async client. So to be able to use asynchronous with HTTPX, you have to use the async client. The default HTTPX out of the box experience with the client is going to still be synchronous. So it's going to mimic a lot of requests, but at the same time, it's going to still give you some of those benefits I mentioned before, which are about performance, HTTP connection pooling. You can get all those benefits without using the asynchronous part. But once you truly understand and dive in on the asynchronous part, you'll now be able to perform a bunch of requests simultaneously, which is pretty awesome. So you can see here, I basically used a async context manager to get a client. And then when I've done that, this request can happen asynchronously. So if anything wants to put this into an event loop, it can, because this won't block. It won't block other IO happening at the same time. So now we're basically ready to use this with an async runner. And so we'll talk about that in a second. Down below, same thing. I changed grab speakers into be an asynchronous function, changed that initial request for the speakers page to be asynchronous. Doesn't have much effect on performance because I still have to make that initial request before I can go and make all those other requests. That's where the real magic is right here, is I'm going to replace going one by one in a loop, this for speaker and speakers, and grabbing each of them like in series with an asyncio.gather, which this is pretty powerful. With this asyncio.gather, we're going to be able to take a bunch of tasks, gather them together, and then request them all at once simultaneously. So the async process takes over, the event loop handles all the communication and the scheduling of those tasks. And then I'll kind of talk about that here in a second. But that's the basics of it. Important again is the async context manager. If you're going to do anything async with HTTPX, you're going to want to use this context manager. You can do it without the context manager, but you'll need to make sure you call client.aclose, which is not obvious since we're usually used to closing files with the close method. There's an asynchronous close method as part of HTTPX stuff. Just use the context manager and your life will be easier because you don't have to worry about cleaning up those kinds of connections or closing any kind of connection pools, because under the covers, HTTPX is still building a connection pool, and you want to make sure you clean that all up before you exit your program, or else you could leak memory or other random things along the way. This is where the real magic is, though. This is where we get to fully leverage async IO and pass it a bunch of tasks. I know what you're all thinking. What in the world is going on here? Like, what? This obviously feels a little maybe foreign to folks who are been around Python for a while. But what we're doing is we're creating a list of tasks using a list comprehension for every speaker that we got out of our request initially for the speakers. We use Beautiful Soup to grab each of those speaker links. For each of those speakers, we're looking for their attribute of the href. So the original, actually, I'll show you the code because it might be easier to see all of it. If we look at this code and this is the not quite async version yet. Let's go make this asynchronous so you can see it in, we'll check out the main. I pulled, so the code I'm looking at here, if you want to play with this, you can, there's a link at the very end to my GitHub where there's this scrape Twitter handles repository. I made each commit and commit message show you kind of the initial state of the program. And then I basically kind of cranked it up each step I'm showing you in the presentation. I made a commit for each of those steps so you can kind of follow along in the commit history. This is the more final product version of it. So if we look here at the speakers, oh, this is, wait, I went one too far. Let me check out this one because this is not here. Okay, this is good here. So the select here is looking for talk title links. That is basically the link to each speaker page. So I'm using just Beautiful Soup here, which is a fabulous library, fun to use. And I will grab each speaker and pass them into this grab Twitter handles. And from here, I'll show you the code again. We're looping over each of those link objects. So these are all Beautiful Soup-based objects. May actually make more sense if I just run it and debug so you can see it, which is also another benefit of using async.io and having a cool tool like PyCharm, is it's very easy to run the debugger and debug this asynchronous code as opposed to threading. If anyone's ever messed with threading and trying to spawn a bunch of threads, it can be difficult to debug that code as opposed to this asynchronous code, which is all running in one single Python thread, but using the asynchronous event loop to schedule those tasks as they happen. So you can see right here, the speakers is a result set coming from Beautiful Soup, with each of them being a link to each speaker. So you've got
one thing that may explain it to them is the star there, like the args.
Oh yeah, but I'm getting to that.
Okay.
I'm getting to that, Joe.
Yeah.
So the bit here that Joe was bringing up that I was getting to was the first bit we want to do is create our list of tasks. The gather method of async.io is going to take not a list like a Python list. It just takes as positional arguments each task that you want to run. So this star in front of this list comprehension is exploding that list into individual tasks that are passed as positional arguments to the gather function here. So that's why the star may be the most foreign part of what's going on here for you. So that's explaining this bit here. So we've got our event loop. We've used async.io to gather together, 30, 40 tasks, which are all the URLs to go grab simultaneously, and then the magic happens. So we make sure, to do this, you have to make sure whatever you're calling, whatever you're gathering has to be asynchronous. So the first bit here is making sure you've got async in the mix. If you are using some kind of synchronous client, like for example, if you have if you don't have the async client, but you have the regular client, you also risk basically locking up the loop while it waits for this one to finish, the next task to finish, the next task to finish. You have to make sure that every bit of your asynchronous awaitable function can return fully asynchronous so that the event loop can continue going even though it's waiting on IO from the network. So we're really leveraging that event loop to send a bunch of IO intensive tasks, and then we'll wait and literally await their response. You can see the await keyword right here. We're awaiting that, and we'll be returning that once all the tasks in gather are done. The code for that gather basically puts them into responses.
So that client get that, even though it looks like a function call, that returns an object in async that's waiting to be iterated on or
yes.
processed.
Yep. Okay. Yeah. So you can see the next step here is for every response that we got back from this gather. So every task is going to have an entry of a list. It's a list of responses. Well, it's a list of tasks returns. Now, one thing to keep in mind, if you are using gather, there are two modes of operation here that you might want to be aware of is when it comes to exception handling. I'll talk about that when we get into exception handling, but you want to be aware that there are different ways to handle exceptions. One is you just ignore the exceptions, they get put into the responses, or you handle the exception at the time it happens, and the other tasks will continue running because they've not been stopped or canceled just because one of these tasks cancels. So if one of these were to fail or give you like some kind of an exception, it wouldn't cause all the other requests to fail as well. So that is making sure your tasks are async. And now we need to run it. So before I did my first script, let me go back down here. We'll go back to the initial non-async version of this. Here we go. I just ran this as a command line script, just calling my function grab speakers. When I have updated this for HTTP2 and for asynchronous operation, I need to kick off my asynchronous. Oops, didn't check out head. Let's check this out. There we go, check out main, my bad. Okay, I needed to change this to now use async.io, the event loop, to run my grab speakers. So that's the main reason why this grab speakers is an asynchronous function, is so I can call it from the event loop and basically run it, passing it in the starting point, which is the speakers URL. Once it has that speakers URL, it can now run the rest of this, which calls the grab, it basically awaits grab Twitter, which is where I do the gather. So you can see we've got our async grab Twitter, which has our asynchronous client. And that is where we now, inside this asynchronous client block, is where we grab our await for all those tasks to finish. So does it work? We do. So downloading the speakers now went from almost 25 seconds to just under 3 seconds. So it's a little more than 2 requests added together. I imagine there's still some overhead there and some traffic caused by me requesting a bunch of pages simultaneously, but it's definitely a lot faster than waiting for the 3 seconds for that all to run. So if I stop this right here and rerun, you'll see I'm just calling this live against the DjangoCon Europe site. Yep, 2.8 seconds. I went to each of these pages and grabbed each of their Twitter handles off of the subsequent pages, as opposed to running it all in series. Where does this go from here? So we've accomplished and sped up our program by a tremendous amount. One thing I've not shown you, but I think is important, is going to be adding exception handling. And if you are familiar with requests, requests has a method on the response called raise for status. And if you're not familiar with that, I would make sure you go back and kind of read the docs on it, because it's super handy for handling exceptions and errors. If there is not a 200 status code on this response, this raise for status will raise or bubble up any exceptions like 404 errors, 500 errors, any other response code that you'd want to handle that is not considered normal. You can now do that with this. So it actually makes it very easy to handle exceptional behavior. So you can make a decision on, in this case, HTTP error is an exception as part of HTTPX that is kind of an umbrella exception, but there are finer grained exceptions in there. So if you wanted to handle a not found and do something different, like redirect or go search in another spot, you could. Or if you wanted to handle a 502 gateway error in a different way, you could also do that. So you can actually make some logic decisions based on this error handling. What is kind of probably tricky and you're not seeing is that in the current status of this code, when I go and request these pages, I call client.get. If there's a 404 right now, if I just add in, I'm going to add an S to the path right here, and I'm going to run this code, I don't get an error. It doesn't bomb out. Even though there was a 404, there was an error. It just ran really quickly and gave me no return. But I got no feedback as a developer that something was actually wrong, and no way to actually handle that specific error. So we can actually add in that raise for during our try except loop. Another way you can do this, actually I'll go ahead and keep it 404, is HTTPX has nice log levels you can set. So you can actually read from the environment. Like HTTPX will have a couple environment variables it can read from the environment. The main one you'd probably be interested in is this HTTPX log level. If you set that to debug in your environment, you'll get some nice feedback on what's actually happening. There's other environment variables for setting up custom certificates. So if you wanted to run against a self-signed certificate or some internal only certificate, it makes it easier to do that with those environment variables because you're not trying to like add stuff to your system's root certificate store. You can actually override that with these environment variables. But I'm going to show you the debug log one because that's probably the most useful right now. So I'm going to go in here and edit my run configuration. I'm going to add in that environment variable. There we go. And we'll set it to debug. And then we'll run again with our error, with our 404. So if I now run, you can see we got our 404 not found. So without having to change any of my code, just adding in that one environment variable into the environment where it's running, I get more feedback. And if I fix my issue and rerun the code, you'll now see that we get all the requests logged out to the terminal. So if you're trying to figure out what's going on, where things are going, if it's actually calling all the URLs you expect it to call, just enabling that one debug will actually go a long way to making sure you have an easy time of debugging this code. So I included in the slides, which actually are also up on my GitHub. If you go to GitHub and look for 2021 IndyPy, you'll see the title of the talk in my repositories. All the links to material I used are in here. So the async task or running task concurrently. This goes over how to use Gather and other options for Gather. You can do things like shield certain tasks from being canceled. You can cancel tasks that are running. The Beautiful Soup, which is awesome. Beautiful Soup 4 had a pretty recent release. HTTPX for asynchronous library. PipX for installing awesome tools. And then here's the link to that repository that has the code that I've been showing off and running right here inside of this. One other bit, the code I showed, maybe go back real quick. Ooh, my computer is hurting. Oof. Here we go. Okay. The code I showed right here, I was kind of toying with whether async was going to like slow down if I was using Beautiful Soup here to do this processing, because Beautiful Soup itself isn't necessarily an async library, but in itself, it doesn't do any IO. So I don't think in the end it did slow me down. So the code you'll see in the repository has this async. Make sure I'm on the right branch. I am. Okay. It has the all the async calls happening in this one await. So we basically run the loop, do the first request, await that, which there's only one thing that's going to happen. So it basically will stop here while it waits for the return from the client get. And then we do the Beautiful Soup to get the speakers. And then we call the next one, which is where we do all the parallelization of getting all the speakers. I couldn't see any optimizations to make here that would make this any faster. So I tried a couple different ways of passing in and gathering together tasks here instead of gathering together the client requests. Because I could have called in this list, grab Twitter from the below function of the grab speakers. And it didn't seem to make a difference. I tried it both ways and got the same result. So depending on your situation, your mileage may vary. And I want to thank you all for listening. Any questions? I'm happy to take questions and at least share what knowledge I learned along this journey going to asynchronous.
I like this because I built a spider similar way with requests. And what I actually wound up having to do is to make a static method that you provide the URL and then wrap that with another async method that gets the event loop and runs an executor. And then I have another async that does the gather for that. So it had to have one other layer of abstraction, which I guess is what's happening internal to the HTTPX.
Yeah.
Where it's doing that static request as an async method.
Right. And then HTTPX is also managing all that connection pooling under the covers. So it's not opening up new requests, like new TCP connections, because
Right, which I think I've got multiples going on, because my spider hits like 1,000 different servers
yeah,
looking at our blockchain nodes. So I think I'm going to do a refactor with that. So it's really cool. The
yeah.
other thing with the returns, I do it like a JSON, dictionary return, so that I can do the error or the success path. So without having to echo it, if you have a return of a bigger data structure than just a single Twitter handle, then you can do the processing externally and seeing whether it was good or bad. Right, which for a utility like this doesn't make sense, but if you're integrating in a system.
Yeah, at some point I had to deduplicate. Where was that at? I swear I'm on the latest here. Yeah, no, I was using a set someplace, but I think I must have fixed that bug. There was another, like, I was getting in the responses when I was doing it the other way. That's what it was. Because if there were multiple Twitter handles on the page, I would get like a list of things, and I had to then basically compile them all back together. This is a little cleaner because it's grabbing the first one.
The other thing I found parallelizing with async is that some of the IPs I have, it's a spider of servers that may not be up, and I was giving them 3 seconds to time out. So serially, that was massive. And when you're doing them in parallel, your runtime is worst case that timeout rather than serialized all the timeouts together.
And you can set timeouts on the tasks here as well. If you want to ignore tasks that are running longer than some amount of time, you could set one timeout for the whole gather.
Does that raise an error, or
That's
is it just show?
good question. If we look at the resources, I think it is mentioned here in the doc, so we can actually go to the docs, which is kind of fun.
It seems to be the common use for async. It's the reason both of us dove into it.
Yeah, see, there's a you can set timeouts for specific awaitables, and if a timeout occurs, it raises a timeout error. So yes, it will raise a exception.
So that would be in your second async function that rolls them up, that you would capture that and log it or whatever.
Yep.
Yeah.
Yeah, I just find async is so much cleaner to me than to solve this prior to asynchronous in Python. You had to use threads or a multi-process, and then you're managing a lot of state, talking back and forth between those threads and processes. Here, it flows more naturally to me as a Python developer who's never done a lot of threading. This makes a lot more sense to my brain.
Maybe you touched on it that I missed. Did you compare putting your beautiful soup parsing inside your context manager, or
I did.
Did you always want to leave that out?
Yeah, that was one where I tried it in and tried it out, and I got the same result. So maybe it made a marginal difference that I wasn't seeing with my time, because also there's network traffic and overhead. I'm dealing with the internet here.
Your latency is probably higher than either way of that going.
Right.
I was curious if you wanted to
go ahead.
If you wanted to assert that the async client got cleaned up, before the rest of the beautiful soup stuff happened. That way, at least that much is done. And I don't know if it even matters though.
Yeah, I don't know if it mattered, but yeah, with this pattern here, the client is fully cleaned up and closed. So any memory that would have been used for that is like out of the way now.
Right. I think if you were doing something from beautiful soup to go out and get a local DB value or something, it really makes sense to tuck it inside the async. If it wasn't just raw local processing.
Yeah, because the other way I had it was, instead of the gather just calling client get, I had the gather calling grab Twitter. So I actually had moved that whole gather bit down into here. And so I was gathering together a set of asynchronous functions that would do some work independent of one another, as opposed to just go do all the work first, grab all those responses, and then I'll just handle that at once. So it probably made a difference because I'm only calling this stuff, this like beautiful soup stuff, well, once for every response. I guess that's about the same. It's really not. I don't know if there's a big difference there. But if you haven't had a chance to play with the beautiful soup, it is so fun. one thing to note, you'll kind of see this like shorthand I'm using where I've created a beautiful soup object called soup, and then I just call it. When you instantiate a beautiful soup object, it basically instantiates the equivalent of a tag in Beautiful Soup's world. And they have a shortcut, since basically find all is the most common operation you're going to do against a tag, is to try and find stuff inside that tag. The shortcut is basically if you call the instantiated Beautiful Soup object, this is the equivalent of calling a tag.findAll. So this is what this is shorthand for. I contemplated putting the find all back in there for clarity, but that's basically the only thing most people do with Beautiful Soup anyway. So that's why they made that shortcut.
Yeah, it's a neat trick.
Yeah.
Yeah. And what's nice, actually, if I come down here and put the breakpoint here, again, I can go on about Beautiful Soup. We could probably have a whole nother talk just on Beautiful Soup because it's lots of fun.
Multiple talks.
Multiple talks, yeah. Once you get down here, the link object, you'll see it right here, is a tag. It's a Beautiful Soup tag class. And it has attributes for href and rel, any attributes that would be in that tag. And it has lots of other data on here. So you've got a lot of power at your fingertips. You're not just dealing with strings in Beautiful Soup. You're dealing with like an understanding of the DOM and the document that you've been passed. So that's why you see link looking for the href attribute. And then I parse that with URL parse, and I grab the last segment of the path. So that's how I can grab, no matter what Twitter, blah, 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 / something, something, something. I just want the very last part of that path. And that's what this is doing for me right here. It's basically grabbing the last part of the Twitter path, which is their username. If I just hop over that, you should see, I guess because it's a loop. Here we go. I'll put another breakpoint and just continue to that one. Oh, continue to do that one. Continue that one. There we go. And so now Twitter handles should be populated with all the goodness here. Twit handles, I should say. So it's just a list. Actually, it's a set. I did it as a set to reduce duplicates. That was the duplicate part.
Yeah, line 15,
I made it a set. There it is. Yes. So I was like, where did that go? Here it is. So basically, I made Twitter handles, instead of making it a list, I make it a set. So anytime I would append a duplicate to it, it just didn't care. It wouldn't add a second one. So sets are nice for deduplicating your data like that.
I hadn't played with that raise for status either. That's a nice little shortcut.
Oh, it's a super
I think you're going to cut about 20 lines off of my 80-line script now with my refactor.
It's amazing when you can use actual exception handling for real exception handling, like literally handling exceptions and doing another behavior.
Yep. Use it and it's cheap in Python. It's made to work that way.
Yeah, I think that's very different. Maybe somewhat different than other languages. Is that Python's exception handling is you could put logic in there and go down other code paths. Exceptions aren't the end of the world.
I have a question that
yes,
I'm afraid I already know the answer to, but I'm hoping I don't. So for async stuff, you have to be using a library like HTTPX that has that capability already implemented, right? Because I guess like my use case would be there's this library that is pinging our database, and we have to use threading to make it concurrent. And now, if the library isn't set up to use an async to have async functionality, is that just kind of like where we're stuck at? Or
you can hack around it a little bit. If I can share my hack for request to show you how much uglier it is. But essentially, if you have a static method that you can call that's self-contained, you can use asyncio.getEventLoop.run an executor, and that's essentially running this single standalone method. And you still have that all stand up and tear down like Calvin was talking about. So my request is starting a whole new connection to the server rather than efficiently using it because it's not expected to be running in parallel.
Yeah, I think we tried that and ran into a roadblock and just decided to, well, whatever, let's just use threads. But yeah, I am open to hacks. Because in this library, I went down through the source code and like layers and layers and layers until I finally found like the request part of it. But it obviously you can't, like if you're gonna say spin this up on a serverless, you can't go in to the source code of a library on serverless, right?
I mean, you could.
You could, but that would be just, I think at that point it's more work than it's worth.
Yeah, I wonder if you couldn't, if it's using requests, HTTPX is mostly a drop in there. So you could monkey patch HTTPX in for requests in that case, or you could just make a pull request against whatever thing you're using and tell them they should use HTTPX.
Right. Yeah. I think that's something that I should kind of bring up with the Touchbase next time. So yeah, thank you.
No, you're welcome. Any other questions? Actually, I didn't look at the
There's,
chat.
I was about to say, there's one in the chat.
Go into the chat now.
From John
Okay.
R.
Oh yeah, so ideas around an asynchronous strategy to only fetch data based on status change once a new event is added to Twitter. That's tricky because Twitter itself doesn't give you like a real-time API, like where you can connect to it via WebSocket. That would be probably where you'd want to use asynchronous for something like this. Like for example, using channels in Django to listen on a WebSocket, like a Discord. And Discord has an API that supports real time. So you connect to a WebSocket, you receive events in real time. You're not continually pulling or getting webhooks when there are events. If you had, maybe you can give me a little more detail on this one. Like for example, if someone sends a tweet, you would want to react to that, or you're looking to build some kind of like a fire hose to collect those into a database. I don't know if John's still here.
Yeah, I would think the API that Twitter has, you can stream filtered a certain way, and it seems like something like that would be how you would process it.
Right. And then you could, if you were doing parallel request, you wanted to do parallel requests to grab additional data, that's where this would really come into handy, using HPX to gather together tasks. Maybe you batch them in so many, you gather so many, go for a batch, gather so many, go for another batch. I can see that. Any other questions in here? I'm just going back and forth. Oh yeah. So this will be on YouTube for sure. Oh, thanks for posting the GitHubs. So yeah, Laura's all over it. She gave you guys all the good links in the chat.
Have you done anything with blocking generators with async? I know I had to go to Threads with a recent thing where we're getting server sent events that essentially is a blocking generator for messages. And so I've got 3 different queues. And so I'm running 3 different threads, which then you have to wait till, you can say kill all the threads at the end, but you have to wait till it gets at least one more message for each of those to shut down. And it's kind of nasty. But I didn't know if there's an async wrapper around like an infinite generator type of methodology where it would just look at that, because it seems like it'd be blocking in any context.
Well, I think you'd be blocking any content. I have not done that.
Unless the actual generator was built with async in mind, I think you're kind of hosed.
Yeah, again, you'd have to really, once you go, like when you start thinking async about the problem, and maybe I should reiterate this for those in the crowd. Async is not the like silver bullet solution to all your problems. If you apply async in some cases, your things could go slower. Just disclaimer right there. But in a case where you are doing something where you are waiting on messages from a generator or wanting to send lots of things in parallel, async seems like a good go-to, but you do need to kind of adopt async throughout the whole bits of it. Because if you have one spot in there where you've got a blocking call, you basically mess up your whole event thread, your whole event loop. So async, you don't add it in. And there's a good talk from Andrew Godwin from last year's Python or this year's Python Web Conference. He talked about this specifically, is don't add in async for no good reason, because you're going to just cause yourself an additional level of like possible headache when debugging. Now I find it easier level of debugging than threads. So I will recommend async over threads day in, day out. But you may have an issue. And so this is something we did in the past, might be of interest. Some libraries are not asynchronously compatible. you are going to need to break out into a thread to be able to talk to it from an async loop. So you can combine, we did a tornado server that talked to a Bluetooth device. The Bluetooth library was not async. So that broke out into, I think, actually using the executor you were just talking about, Joe, to talk to the Bluetooth part and maintain state in instance variable of some kind or a global. It was not pretty. That's when things get not pretty. It is possible, but as much as possible, you're going to have to make sure the async part of your code stays async and never gets blocked.
Yeah, that's where mine's not pretty because you've got multiple threads and you're defining
Yeah.
globals and using them as flags for killing. And
luckily, I just had one thread to talk to the Bluetooth because only one device I was talking to. But if I was going to talk to multiple devices, I would have had to spawn multiple threads per
yeah, that's what I'm
connection.
trying to program because we could have multiple streams as we get more directed filter streams. It just grows.
Mm-hmm.
But your multi-processing or your multi-threading get really complex.
It does.
And but if you're CPU limited, that's where you kind of got to go. But if you're IO limited, async's a lot easier.
Oh yeah, for sure. It looks like John just joined back up. John, we just went over your question. Oh,
Sorry
he's
you
there.
missed it.
Yeah, sorry, my Zoom crashed, so I'm apologize for that. But
Oh, no
yeah,
problem.
it was more about I guess it was more of a basic question about the use of sync versus async, and I guess I'm very kind of in the very elementary stages of Python learning. And normally when I think about sync, I think about like streaming data, like using a Kafka.
Mhm.
Kafka topic and dealing with different, streaming events versus when I think about async, I think more about just regular batch processing. But yeah, so it was just more of an elementary question on the differences between the two.
But there's probably async libraries for talking to Kafka. So you could actually basically stick a task on the queue and you'll just get it called whenever there's something sitting there for you to process.
Yeah,
So that
yeah.
I think would apply there.
Okay. So just wait on an event change, then perform an action based on the status switch okay.
Yeah, it may
Gotcha.
depend on the library you're using too.
Mm-hmm.
But basically you can run a command that doesn't await, but doesn't block the main Python process.
Mm-hmm.
And at that point, you can have many of them running, all waiting for something to come back on the queue.
Right. Gotcha. Thank you.
Oh, my dog wants in.